So, as I pulled up my lesson to record the last video for this lesson, I realized that I made a mistake on this one, so I'm going to start by fixing my mistake. We've got the 1 minus 2 should have been a negative 1. Not sure why I decided to ignore the fact that there was a 1 there and just grab the negative 2. So what we have instead is negative 1, which then when you factor it equals that negative x. The last piece of information we're going to take a look at for this lesson is what's called the intermediate value theorem. Now, the actual wording definition is a little bit confusing, but once we apply it, I think you'll understand it's pretty much common sense is what this is. I'm really not sure why we need a theorem for common sense. But anyway, if f of x is a continuous function, like all polynomials are, so we're going to be using this with our polynomial functions, along the range of a to b. What this is saying is that the x values are going from a to b. So for example, if your function is continuous, you don't have to pick up your pencil to graph the function between 2 and 3, for example. Then, for every y value, this d right here is representing any number that's a y value between the function evaluated at a, so we're pretending that's 2, and the function evaluated at b, which is 3. So evaluate the function at 2, get a y value. Evaluate the function at 3, get a y value. For every y value in between those answers, there will be a c value, another x value, between a and b, such that f of c equals d. And I'm sure that is all crystal clear for you, and I don't even need to do any examples because it makes perfect sense. Really wordy, so let's apply it and see if you can understand what it means when we're applying it with actual numbers. Alright, so our example says, show that for this function, it has a real 0. This is really what we're going to be applying the intermediate value theorem for, is to find zeros between negative 1 and negative 2. So negative 1 and negative 2 are our x values. When you go back to that vocab sheet we were looking at, that would be the a and the b. So along the continuum, or the range of x values between negative 1 and negative 2, we're trying to show that there will exist a 0, a y value of 0. So we're going to start by substituting the negative 1 and negative 2 into the function. Alright, so substituting these into the function, so we're going to evaluate the function at negative 1, and when you replace here the x with negative 1 and you cube it, you get negative 1. When you take negative 1 and square it, you get positive 1, plus the 1 on the end will give you a value of 1. So the ordered pair we have is negative 1, 1. Next, we're going to substitute the negative 2 into the function, so we're going to evaluate the function at negative 2. Negative 2 cubed is negative 8. Negative 2 squared is 4, plus the 1 on the end gives us a y value of negative 3. So we have the ordered pair negative 2, negative 3. So what the intermediate value theorem says is that between negative 1 and negative 2, there will be the entire range of y values between 1 and negative 3. 0 is between 1 and negative 3. So the intermediate value theorem says there will be a 0 between negative 1 and negative 2, between the x values. So since that may still not be clear to all of you, I have a graph here, so we can graph those 2 points, negative 1, 1, and negative 2, negative 3. Because our graph is continuous, there is no way to connect those 2 points without also crossing the y-axis. We're not actually asked to find the 0, we're just asked to show that there is a 0. So either saying, due to the intermediate value theorem, because 0 is between 1 and negative 3, there will be a 0, or you can graph it and show graphically that the graph will have to cross the x-axis at some point between those 2 ordered pairs that we just got. The other way we can apply the intermediate value theorem is by looking at a graph and determining where the zeros are. Now this one, the zeros aren't nice ordered pair integers, so That's why we're asked to give the 1-unit intervals in which the graph has a 0. So when we're looking at this first 0 right here, I know that at -2, we'll just estimate we've got a y value of about 2. So we've got the ordered pair -2, 2. And then -1, we've got the y value of, we're just going to estimate and say that that is -4. Oops, sorry, -4. So because a 0 occurs between 2 and -4, the 0 of the function is between -1 and -2 and -1. So the first interval on which we have a 0 is from -2 to -1. We've got another 0 right here occurring between the x value of 0 and the x value of 1. Another 0 occurring here between 1 and 2. So when you're asked to give the intervals on which a 0 occurs, you're looking for the x values. And our final 0 is right here between 3 and 4. All right. Hopefully the intermediate value theorem made a little bit more sense when we actually applied it to the graph. If not, make sure you bring your questions to class and we can go over them then.